This is question 4 for P3 Solution Bank chapter review 6, differentiation. Okay, this question gives us a function and it says, what is the largest k if the function is increasing? So the first part I want to unpack here is this statement of the increasing function. So increasing functions, when they're increasing when the gradient is positive. So an increasing function, our f dash of x, will be larger than 0. So we need to find the gradient, we need to find the first derivative, and we need to find out where is it larger than 0, and that will help us find our k values. Okay, so our k values represents what is x? What is x? What is x when this functioning is increasing? In previous questions, I've used the product rule, but this one, because there's a whole function in the denominator, I would actually suggest to use the quotient rule, not the product rule, to solve this one, which is what they did in the solution bank. So if you find the solution bank online, it's a really useful tool to solve these sorts of questions. But the purpose of these videos is to help those who still struggle even looking at the solution bank. So, okay, quotient rule is u dash v minus v dash u over v squared, where u and v are parts of the function. U is the numerator, and so our u in this case would be this x, and our v would be x squared plus 2. Okay. So we have u as x, and we have v as x squared plus 2. U dash would then just be 1, first derivative of x, and v dash, first derivative of x squared plus 2 is just 2x. Quotient rule, following how it goes this way, that's number 1. Then it goes this way, that's number 2. And then it's all over v squared. That's the third step. Okay, so u dash v is 1 times x squared plus 2. Let's put that in black. V dash u is 2x times x, so 2x squared. Don't forget that it's negative, and it's all divided by v squared. So x squared plus 2 squared. Okay. Simplifying this a little bit, this is going to be our dy dx, or our f dash of x, depending. Always use whatever they give you. This one they used f of x, so it would actually be f dash of x. So let's just, whatever they give you in the question, you just use the same thing. Simplify this a bit quickly, plus 2 minus 2x squared. Okay. All over x squared plus 2 squared. And that will simplify some more to x squared. Wait, we want to divide this a little bit. X squared minus 2x squared. So it'll be, let's do just the 2. You can see it. 2 minus x squared. Okay. Following on the solution bank mark scheme. So if we want to find out where the function is increasing, we said that this f dash of x has to be larger than 0. So we can just let this be larger than 0. Obviously, if you times the denominator by 0, it's just going to be 0. So what we really need is for this to be just the numerator to be larger than 0, and we want to find out where that is. They had square brackets on the k. Okay, square brackets means including. So let's just add the including there. So x squared is larger than negative x squared larger than -2. Be careful here. When you times or divide by a -1, when you times or divide, then the sign switches around. So from this would switch to this. We're working with inequalities. Okay, so we're timesing or dividing by -1. So our sign will switch around. Okay. Okay, so then we have x is going to be smaller than or equal to, oops, sorry, something's wrong with this. There we go, plus, okay. That wouldn't have worked, that would have been non-real. So the square root of 2 is what we're working with. And of course, when you add your own square roots, it's plus or minus. Going from the mark scheme, this makes no sense. So x can't be larger than both. Anyway, going from the mark scheme, your x is going to be between negative square root 2 and positive square root 2. And these are our k's. And since k had a negative k and a positive k, we have k as going to be equal to -2. Excuse me, square root of 2. Okay. Not so sure about this notation. Just scroll back to sort of the logic of it. Something to think about for another video. Maybe you can post a comment on this notation here. But it's more or less completed. Number B asks us to find the exact coordinates of the point of inflection. Okay, so we had f of x as originally being 2 minus x squared over x squared plus 2 squared. And we know that point of inflection, we need the second derivative, f dash dash of x is a second derivative, must be equal to 0. So we already have the first derivative. Our first derivative we worked out in the previous question. Our first derivative was equal to 2 minus x squared over, oh, this is the first derivative, oopsie. Okay, so if this is our first derivative, we have to derive it again. So we can use the quotient rule again. Quotient rule again, u dash v minus v dash u over v squared, quotient rule. So I always pick the numerator as u, always pick the denominator as v. This is an interesting v, it's going to have a chain rule. So this is -2x, the first derivative of that, and then v dash chain rule. So we bring down the 2 goes to here. Okay, then whole function, change color randomly. Let's choose whole function, x squared minus 2, and we minus 1 from this, okay, which is just 2 minus 1 is 1. So just to follow with the color, that went to there. And don't forget to times by f dash of x. So you times by the first derivative of what's inside the bracket. First derivative of what's inside the bracket. So that's going to be 2x. So first derivative of what's inside the bracket. We used a chain rule here. Okay. Let's just simplify our v dash a little bit. So that becomes 2 times 2 is 4. 4x, x squared minus 2. Okay, I'm just going to put a little line through there so I don't get confused. I'm going to move this down. So when I'm making my u dash v minus v dash u, so we first go this way, 1, then we go this way, 2, and then the third thing is to square the v. Okay, so we have, let's do it. Negative 2x times by x squared minus 2, and that was originally a 2 squared, minus v dash u, 4x x squared minus 2 times by 2 minus x squared, all over v squared x squared minus 2 squared, x squared minus 2 squared squared. Okay, that's our second derivative. So this was f dash dash of x that we needed to work out. Lovely P3 questions. Let's simplify this a little bit. So once we've got to this part, we have to simplify. Let's first just make it a little neater. Also trying to follow the mark scheme a little bit. So just make sure all is in the same order as the mark scheme. You obviously don't have to do that. That's just so it's easier for students to follow on what I've done. Okay, and this 2 times 2 is just 4. So what you really have in the denominator is something to the power of 4. So that's a power raised to a power. Okay. From here, so that the goal is to simplify it a little bit, as much as possible. Simplify it as much as possible. Just seeing what simplification, they took out a highest common factor of 2x x squared plus 2. So let me get that in color for you. They took out a common factor of 2x x squared plus 2. Interesting. Okay. That would change this sign. So let's just do that middle step first. If we have squared 2, I see. Interesting. I'm just going to follow the mark scheme. So if we took out a common factor, so let's put that we put out a highest common factor of 2x x squared plus 2. Okay, this is going to be our highest common factor. So certain things will get changed. So our f dash of x equals 2x x squared plus 2. Didn't need it. I was going to change some stuff, but I think I'm going to just follow this rather. So you open up your brackets. You want to ask yourself what's left over. Well, if we had to divide this by 2x x squared plus 2, you ask yourself, well, what would be left over? What would be left over? There's for sure something wrong with this because that won't work. Let me go back and see. 2x x squared plus 2. Going back. I found it. So here's my mistake. Doing my mistake in blue. That's a plus. So our v was a plus. So fixing my mistake in blue. That's a plus. That's a plus. Then that's a plus. That's a plus. 2 minus x squared. And the denominator, that's a plus. Okay, I think those are all the mistakes. Now we can work. So if that's a plus, that's a plus. Goodness me, lots of writing errors. Talking and writing at the same time, not a good combination. Okay, so now we can do it. So you ask yourself, what is left over? Well, we took out 2x, so it's just -1. And we took out one of the x squareds plus 2. So there's an x squared plus 2 left over. There were 2 of them. We took one out. Then from the second term, we took out 2x x squared plus 2. So the whole x squared plus 2 is out. We've got 2x left over. It was 4x, now it's 2x. And we have 2 minus x squared. Oopsie, left over. Yes, that's correct. All over x squared plus 2. Power 4. So mark scheme is differing from mine again. Just check that. That's 2. That was a 4x. We took out 2x, no x. Okay. Self-check. Good. They just cleaned up the second bracket. 2x x squared plus 2. Clean up the second bracket. You just make this look more pretty. So we end up with negative let's do it like this. So negative x squared, negative 2, negative 4 plus x squared. There we go. Denominator stays the same. Our x squareds cancel out. We have, in fact, a negative 6 here. Okay. So, a bit long-winded, but these questions is going to be how come mine canceled out and theirs didn't? Why? X squared. Oh, there were 2 here. Try and do it too fast. So it'll just be x squared. So this was 2x squared. Okay. Negative 6 plus x squared. All over x squared plus 2. Right. So this is the form, most simplified form. We had to prove when this was f dash dash of x, just to bring us back to what we need to prove. We want where this is equal to 0. Okay. So when it's equal to 0, obviously, if this is equal to 0, let's just write it like this. So when our second derivative is equal to 0, we have a point of inflection. First thing, obviously, if the denominator is times by 0, you don't need to worry about it. So we end up with 2x all of this equal to 0. So we have 3 options of what's equal to 0. 3 options of what's equal to 0. So 2x is equal to 0, x squared plus 4 is equal to 0, and x squared minus 6 is equal to 0. So we have x is equal to 0 minus 4 squared. So it's going to be plus minus 2. Then no, this was a negative. Oh, this was a negative 2. Goodness me. This won't work because negative 2 can't be squared. So we already can cancel that one out, but 6 works. So plus minus root 6. Okay. So we have 2 options that we can check. How do we check this? Well, sub it back into y. So we do f of 0 and we do f of plus minus root 6. And we check the answers. I'm just going by the mark scheme. When we did f of 0, so you sub in our original f of x, just to tell you what I'm doing. Our original f of x was x squared plus 2. Okay, so if you put 0, 0, this is just going to be 0 over 2. So it's just going to be 0. So this one is 0, 0. And on the right-hand side here, it'll be root 6 over root 6 plus 2. And the answer that they came up with, you can check it on your calculator. It should be plus or minus root 6 over 8. Okay. So we have 3 options, 0, 0, and I don't know which is which, so I'm just going to write it together. I'm assuming the plus goes with the plus and the minus goes with the minus, but I haven't actually checked root 6 over 8. So those are our 3 options. And that concludes question number 4.